Okay, so you had a question when I turned the camera off.
Couldn't you just use factor integer to factor that big number there?
Yeah, we could have used factor integer to factor this number. So Mathematica has a function called factor integer. Oops, sorry, I typed it wrong. And let's see what it says. 113 times 229. Yeah. So factor integer works.
But will not work with 100-digit primes.
Yeah, it becomes harder and harder as you go up. So there's a couple different ways you can factor.
Yeah.
But factor integer is just a function and it has to do something.
Maybe factor integer does this.
Maybe. This is an algorithm that works well for when you have a product of two primes.
Factor integer can do like more than that.
Yeah, so let's go put factor integer down here. So this is a good question. So here's a randomly big number, and factor integer can factor it.
I doubt it would be able to do that if you had like 100 digits. Huh.
Doesn't take that long.
Doesn't take that long. Still. That's a very big prime there.
Yeah, it's finding factors very fast.
I wonder
So
if that's 100 digits.
I don't think so.
I don't know, but it certainly seems to be doing a good job. Maybe Mathematica has broken RSA encryption already.
Or
Oops.
maybe Mathematica is a quantum computer.
Secretly, and they didn't tell anybody.
Oh, no, it takes really taking a very long time.
Now it's just running and running and running.
Oh well.
Oh well. So
It worked up to a certain point.
It worked up to a certain point, and then it broke. But let's go through with 113 and let's do the 30th prime,
300th.
the 300th prime, and the 500th prime. Oh shoot! So Mathematica's running now. I have to abort that calculation. All right. So our factor integer, gigantic number, is aborted. All right. So now we have 1,987.
3,500.
And 3,571. So I get 7,095,577, and factor integer knows how to deal with that.
Yeah.
Okay. So should we use 41 again?
Alright.
Okay.
Now let's try to see if we can find the period. So this is for a 7-digit number. Let's see if it finds the period very quickly. As we said, as the numbers get big, this gets harder to do. Uh-oh.
Hopefully it won't take too long.
Might have been it. Seems like it does take a while.
Yeah. So what do you think's hard about this step 2, finding this period?
There's so much stuff to check.
And the pattern with the powers doesn't repeat that often because you have such big numbers.
Right.
And it's like mod 41, so.
So it's running here. Let's see. I don't know. We could have written the code here to do this calculation a little easier. It has to compute A41 to the R for R getting very, very large, and then mod it out by whatever our number was. What was our number? 7,095,577. But what I could have done is did the mod calculation every time to simplify the calculation, so I didn't have to compute these gigantic powers every time. Because all I'm doing each new step is multiplying by A one more time, right?
Yeah. But it shouldn't mean, I guess it repeats a lot.
Yeah. So we're already seeing with our very naive program that trying to factor 2 4-digit primes multiplied together is getting difficult.
Yeah.
You think it's going to be able to do it?
I don't think so.
You don't think so? All right. I'll tell you what. I'm going to turn the camera off, and we're just going to wait off camera until this finishes running.
Okay.
All right, and we'll time it as well.